Hey everybody, and welcome back to another session from the Net Academy. From the last session, what we covered were what are the different OSPF area types: the stub, the totally stubby, the not so stubby area, and the totally not so stubby area. But we also went into quite a bit of detail into that OSPF LSA or Link State Advertisement Type 7, which is the NSSA external LSA. It advertises those external networks which have been redistributed into OSPF through that not so stubby area or that totally not so stubby area. So type 7s are very important for redistributing external routing protocols like ISIS, BGP, static routing, whatever it may be, into that OSPF routing protocol. What I want to do on this video though is really come away from labs, really come away from the configuration itself, and actually go through a little bit more theory when we start looking into these OSPF area types as to what LSAs should you see and should you not see in these area types. And if we look at a certain amount of routes, which you will get in any network of course, how many routes would you see in that backbone in area 0? How many routes would you see in a stub area, a totally stub area, not so stubby area, and guess what, a totally not so stubby area? And you're really going to see, because those ABRs, those area border routers, are blocking certain LSAs, that the amount of routes that you see in those OSPF area types, they're really going to be less than what you would get in that OSPF backbone itself. So let's get going. And so here's the network, here's the example that we're going to be running through on this session. And it actually replicates that of a virtual network I've got on my server that I'll be using in a further video. But as you can see, we've got area 0 right here. So area 0 is obviously the backbone, it's the transit area. And the reason why it's called the transit area is because all areas 1, 2, 3, 4, 5, they communicate to each other, they reach each other via the backbone, via that transit area. And we've then got 5 ABRs, the area border routers, which connect the non-backbone areas to area 0. And then area 1 is a stub area, area 2 is a totally stub or stubby area, area 3 and 4 are actually the same, they're not so stubby areas, and area 5 is the totally not so stubby area. But the purpose of this call isn't to go through the diagram itself and what is a backbone area and what is an ABR. No, it's actually to show you from a little bit more of an illustrative example what LSAs, what link state advertisements we should see in a stub and totally stub and NSSA and Totally-NSSA areas. And you really see that when the ABRs block and really discard specific LSAs, how that link state database is further minimized. Okay, so let's put some numbers onto the table itself. So if we look at area 0, let's say in area 0 we've got 100 routes. So those are 100 routes which are just inside area 0. We've then got an ASBR, an autonomous system border router, which is actually connected to area 0. There's no rules in the OSPF protocol that say you cannot do that. It's perfectly allowed. So OSPF is receiving an extra 10 external networks via the ASBR. The ASBR is redistributing 10 additional networks via ISIS, EIGRP, BGP, RIP, static routing, whatever it may be, it doesn't matter. ASBR is redistributing, is exporting those 10 routes into the OSPF routing domain. But in area 1, let's say we've got another 100 routes. In area 2, we've got another 100 routes. In area 3, 100, 100, and in area 5, a further 100 routes. And just to finish the picture off, let's say each one of these 3 ASBRs, they are also redistributing in an additional 10 external prefixes into the OSPF routing domain. So when we look at area 0's link state database, how many routes is it going to see in its LSDB? Well, as we could see, we've got 100 times OSPF routes. Now those are intra-area routes. Those are routes that, as I said, are within area 0. That is what an intra-area means. But we can also see that we've got 100, 200, 300, 400 and 500 inter-area routes. So we've got 500, and I'm just going to put int here, intra-area routes, which are, those are routes which are coming from another area. Intra-area is routes in the same area. Inter-area are routes from another area that are being received within that same area as yourself. But then we've got these external prefixes which have been redistributed into area 0 or via the other areas via the ASBR. So we got 10, 20, 30, 40. So we now have got 40 times external network prefixes. So the total number of routes in Area 0's linked state database is 640. 100, 500 plus 40, 640. Now, the Area 1, 2, 3, 4, 5, they might have network devices which aren't as powerful, aren't as high spec as all those routers in Area 0. And so they might not want to receive 640 routes, because those 640 routes is going to take up processor, it's going to take up RAM. And so the operator might go onto the ABR on Area 1 and define a specific configuration. And that configuration is set protocols OSPF Area 1 stub, specifically for the Juniper Junos devices. Now this stub is not just for the ABR, that is for every single router that is in Area 1. And the reason for that is that with the OSPF hello packets, if you have one router that sends an OSPF hello packet with the stub bit enabled, and another router in the same area with the hello packet stub flag disabled, they're not going to form that adjacency. And even if they have the adjacency, if you have one router suddenly a stub and the other router is not a stub, after 4 fails of that hello packet, that adjacency is torn down. So that has to be repeated on every single router in the same area. But additionally, there's a further configuration that you simply have to quickly do on the Juniper Junos device. So this summaries command, this configuration, needs to be on the ABR itself. And what that's going to allow is for types 3 LSAs to go through the ABR from Area 0 into Area 1. But of course we are also going to have types 1 and types 2. So in a stub network you are going to have types 1, types 2 and types 3. But the ABR will also inject a single default route. And that is important because the stub area does not allow types 4 and types 5. They are not allowed. The ABR will simply block them. So for all these external LSAs, these external networks which have been redistributed into OSPF via those ASBRs, the routers in the stub network will not know where to go to, where to send that traffic, because those types 4 and 5 which identify those external networks and who the ASBR actually is, they're blocked, they're discarded by the ABR. So that default route really identifies, you know, that missing piece. If you want to get to these external networks, here's a default route. So if we look at the Area 1 link state database, well, we've still got 100 routes within Area 1. So we have got 100 times OSPF intra-area routes. We've then got a single default route as well. And we are also allowing type 3 LSA. So if we look at Area 0's link state database, we can see that it has here 500 inter-area link state databases. Is that going to be the same? Well, we've got 100 in Area 0, 100 in Area 2, 100 in Area 3, 100 in area 4 and another 100 in area 5. So 100 plus 100 plus 100 plus 100 plus 100 still equals 500 times inter area routes, which are going to go into the link state database for all routers in area 1. And that's it. So if we calculate this now, just quick and easy, we've got 100 plus 1 plus 500. We now have got 501 routes in area 1. So now you can really see the difference between area 0 and area 1. Just by configuring it to be a stub network, we have drastically minimized the size of that link state database and thus protected the processor, the RAM, etc., etc. on those routers themselves. But let's also now look at area 2. So what configuration do we need to do on area 2 on the ABR itself? And the command is pretty much the same. Set protocols OSPF area 1 stub no summaries. That's important, come on to that second. But just like we saw in area 1, this stub has to be configured on every single router in area 2. Again, the OSPF hello packets, if one sending it's a stub and the other router saying it's not a stub, they're not going to form an adjacency, or that adjacency, if it's already there, will be torn down. But that no summaries extra configuration, extra one command needs to go on the ABR. So what then, from an LSA perspective, what LSAs are going to come from area 0 into area 2? Well, of course, we've still got types 1. We've got types 2. We are still going to have our default route because the ABR will automatically generate that default route as soon as we set this to a stub network. But we have configured no summaries here. So we are now no longer going to have types 3. We're no longer going to have type 4. And we are also not going to have type 5. So now you can see the difference between stub and totally stubby. What LSAs you should see and what LSAs you will not see. Now, let's then look at the area 2 link state database. What LSAs will populate that link state database? How many entries should we actually see? Well, again, we've got 100 routes in this area itself. So we've got 100 times OSPF routes. We've also then got our 1 times default route. But then we are blocking types 3, types 4, and types 5. So that's really it. Then the amount of entries of routes that you're going to get into area 2's link state database in a totally stubby area is 101. So let's now look at the not so stubby area. So what command do we actually need to give on the ABR that's connecting area 0 to area 3? And so this is the command that you quickly need to do on the ABR when you want to configure an area to be a not so stubby area. And I did actually just notice a mistake. This was set to area 1, not area 2. I've adjusted it. That's the hazard of doing a good old-fashioned copy and paste. But coming back to the ABR, here you do set protocols OSPF area 3 NSSA summaries. Now the NSSA part needs to be configured on every single router inside area 3. Again, otherwise they will not build that adjacency. Additionally, on the ABR, you need to configure the summaries command. Now, just as we saw in that stub network, this is going to allow types 1, types 2, and types 3 to come through the ABR from area 0 into area 3 itself. But just like the stub and totally stubby, the ABR is stopping, blocking, discarding types 4 and types 5. There is also not a default route. There's no default route that you get with a by default, no pun there, You do not get a default route generated by default via the ABR. Okay, but what you do also now get is the type 7 LSA, the NSSA external LSA. Because we have autonomous system border routers which are redistributing in this case 10 additional networks and routes into OSPF, this type 7 is going to go from the ASBR all the way through the network up to the ABR, where it then summarizes those types 7 LSAs into a type 4 and type 5 LSA. Okay, but the ABR is still blocking these types 4 and 5 from entering the ABR through into area 3, if that makes sense. And moving on to the link state database for area 3, how many routes are we going to see in area 3? Well, we've still got our 100 intra-area routes. So we still have got 100 times OSPF intra-area routes. We now have these type 7 LSAs. The ASBR is redistributing 10 external network prefixes into OSPF itself. We do not have the default route though, so we do not have a default route 000.0/0 coming from the ABR, but we do have type 3s. So we now need to look at how many inter-area routes that are there. So we've got 100 in area 1, 100 in area 2, 100 in area 4, 100 in area 5, and 100 in area 0. So we have now got 500 times inter-area routes. So if we summarize this now, how many routes have we got in area 3? 100 plus 10 plus 500, we have got 610 entries in area 3's link state database. But how is this going to change from area 3 to area 4? Because they're both NSSAs. So here's the command that you need to enter on the ABR for area 4. It's very similar to what we saw for the ABR on area 3. Set protocols OSPF area 4 NSSA summaries LSA default. Now what this is going to do then is it's going to still allow, of course, types 1, types 2. We've got the summaries command, so we're still allowing types 3. This is a not-so-stubby area. We've got an ASBR connected, so we are still going to have the allowance of type 7s. But now, because of this LSA default, we have now got a default route as well. Now this, again, the NSSA part that needs to be configured on every single router inside area 4 that's participating in OSPF. But the summaries is allowing type 3 LSAs to be summarized and sent into area 4 from area 0. But the LSA default is then allowing the ABR to say, well, for all other traffic that's not in those summary addresses, in those LSA type 3s, here's a default 0000/0 route. Okay, but you're still not going to have types 4 and types 5. So let's move over onto area 4's link state database. How many routes are we going to see in the LSDB? Well, just as before, we've got our 100 times intra area OSPF route. We have now got a single default route as well. We have got our 10 network prefixes or routes which are being redistributed from the ASBR into OSPF. So we've got 10 times external networks. So these would be N2s by default. And we are also still allowing type 3s. So we now have got 500 times external inter-area routes. And I'm just going to move the display down a little bit, or should I just zoom out? It might be a bit better. No, I'll just move it down just a little bit there. There we go. And how many routes have we got in total now? Well, we have got 100, 101, 111. So we've now got 611 routes in total in Area 4's link state database. And you can really see now the difference just by a few configurations that we can actually have. And this is why OSPF is such a great protocol, because just by having a stub, a totally stub, and the different configurations, we can really minimize and scale that link state database. But let's finish off on Area 5, our totally not so stubby area. So first, what configuration do we actually need on the ABR? So here's the command that we need to enter on the ABR for Area 5. Set protocols OSPF Area 5 NSSA, no summaries, default LSA. Now the NSSA needs to be repeated on every single router on Area 5 within Area 5 to have that adjacency. No summaries means the ABI is going to block the type 3s, the summary LSAs, and the default LSA will come on to that in just a second. So what LSAs are we going to get in Area 5, this totally not so stubby area? We're going to have type 1, we're going to have type 2, we've got this ASBR importing 10 external prefixes, and they will be shown as a type 7. That is it. If we show now what LSAs are going to be blocked by that ABR, we always have blocked type 4 and type 5. Okay, it is also now going to block type 3 LSAs, and this is important now because we no longer have these summary LSAs coming into this not so stubby area. When we looked at the ABR for a totally stubby area, by default it will automatically generate a default route. However, it is an additional configuration you need to do on a not so stubby area. And the reason for that is because you might have a default route coming in through the ASBR. So you might have a network prefix here which is already 0.0.0.0/0 coming into OSPF. And if we suddenly inject another default route here, we've suddenly got two different OSPF, two different default routes. One saying go that way, one saying go that way, and which way you're going to go, you simply do not know. That's a good little rhyme there as well. So that is why it is an additional configuration. It's not generated by default, because it assumes, we know the same amount of assumptions, but it assumes that the ASBR is going to import some kind of default route. So it's also a safety precaution. So default LSA allows us to generate a default route as well. So let's move on to the link state database for Area 5. I've already started this a little bit, but we've got 100 routes for OSPF. These are the intra-area routes. We've got our 10 external networks, these routes which are being imported from the ASBR. We have then got our 1 times default route as well. We are blocking types 4. We are blocking type 5. We are also blocking type 3. So we aren't going to see these 100 routes in area 0, 1, 2, 3 and 4. So that's really it. So there's total routes that we will now see in Area 5's link state database is 111. And so that's the end of this session, everyone. That is how having a stub, totally stubby, not so stubby area, and totally not so stubby area, and the ABRs allowing and blocking specific LSAs allows OSPF to really scale. In that backbone, we're always going to have, unless you have firewall policies, etc., you should always have all those routes actually seen in that area 0, because it's the backbone, it's the transit area. But again, we might not want all of those routes seen in all those different types of areas, and that's why OSPF has those area types, so we can scale the network, and that these routers which might be less capable can actually keep up with those entries without overloading its memory, etc. So thanks for watching and stay tuned for the next video.